Okay, so we are going to do our our implicit differentiation and related rate notes. All right, so let's get started. You have these steps for that implicit differentiation in your notes, so make sure you work along with me, print those out, and work along with me. All right, so step one is to take the derivative of each term. And remember, anytime you take a derivative of a term that involves a y, you have to follow it with dy dx. All right, so let's go. Derivative of 7x squared is 14x. All right, minus, and the derivative of 4y squared would be 8y, and I follow it with dy dx, or y prime. Our book uses dy dx, so I'm going to stick with that. And then the derivative of 24 is 0. Okay. Now, that next step is to get every term that has a dy dx in it on the same side, and anybody who doesn't have a dy dx has to go to the other side. So I'm going to leave this 14x, and I'm going to take over that negative 8y dy dx to the other side. Okay. Now, if I had more than one term with the dy dx in it, I would do that step 3, which was to factor out that dy dx, but I only have that one term, and this is what I want by itself. So to get it by itself, I just divide both sides by that 8y to cancel it out. So reduce that, and it reduces by 2, so you get 7x over 4y equals dy dx, and that's the way we can find that derivative when we weren't able to originally get that y by itself. Okay. All right, so moving on, let's do the next one. All right, so same thing, we're going to take the derivative of each term. Anytime you take a derivative of a term with a y, you follow it with dy dx. So the derivative of 3x cubed would be 9x squared. Minus, all right, the derivative of 8y squared would be 16y, follow it with dy dx. And then the derivative of 10y would be 10, follow it with dy dx. Okay. Now, step 2, get all of your dy dx's on the same side, and anybody who's not a dy dx to the other. So I'm going to leave this 10 dy dx, and I'm going to take this negative 16y dy dx, and we'll take this term to the other side. So it becomes positive. All right. Now, you want to, at the end of the problem, have that dy dx by itself, and right now you have 2 of them. So what we're going to do is we're going to factor out that dy dx. So if I pull out the dy dx, I'm left with 10 plus 16y. And then to get that dy dx by itself, I just divide both sides by that parenthesis. Okay. Now, before you leave it as a final answer, look at your terms and make sure that nothing reduces, but there's no one thing that goes into 9x squared, 10, and 16y. So that is my answer. Okay. And the next one, it'll reduce, so you can kind of see what that looks like. All right, this note's super important. Whenever x and y are together in the same term, we have to use a product rule. So what is going to be watching for is something like this term right here, this 4xy. Whenever I've got x and y together in the same term, I have to do a product rule. So depending on who you had for BCal 1, is how you set it up. But I make my students, we do a 1 and a 2. My first term I'm going to call 4x, and my second I'm going to call y, and then I need d1 and I need d2, being the derivative. So the derivative of 4x is 4, and the derivative of y would just be 1, and I follow it with dy dx. So there's really no need to write that 1 there. Okay, but y'all remember that the product rule is 1d2 plus 2d1 when you're taking that derivative. Okay. All right, so let's take the derivative. Derivative of 7x squared is 14x. Derivative of 5y squared is 10y dy dx. And then right here, I'm going to do the 1d2, 2d1. So I would do 1, which is 4x, d2, which is dy dx, plus 2, sorry, I'm running into my writing before, which is y, d1, which is 4. All right, so let me clean that up, no parentheses. So we get 14x equals 10y dy dx plus 4x dy dx plus 4y. Okay. So I want all my dy dx's on the same side, and they are, but anybody who's not a dy dx needs to go to the other. So I'm going to take this positive 4y, send him across. Okay, and while I'm doing that, I'm going to go ahead and factor out the dy dx over here. So then I would be left with 10y plus 4x. Okay. So to get that dy dx by itself, I divide both sides by that parentheses, 10y plus 4x. Okay. So now, before I leave it alone, look at your terms. Look at everything in this answer over here and ask yourself, will it reduce by anything? And yeah, it'll reduce by 2. So I would get 7x minus 2y over 5y plus 2x equals dy dx. All right, let's practice another one of those. So again, I'm looking for any time I have that x and that y together in the same term. All right, so I'm going to move it over a little bit. So I'm going to call the first term in this one 2x squared and the second one y squared. So d1 would be 4x and d2 would be, all right, derivative of y squared is 2y, follow it with dy dx. Right, so if I did that product rule, it's 1 d2 plus 2 d1. We'll do the same thing. It's going to run into each other. Sorry. All right. Derivative of 3x is 3. Derivative of 4y is 4. Follow it with dy dx. Okay. Clean it up without the parentheses. If I do that and just multiplying this 2x squared times that 2y, I'm getting 4x squared y dy dx plus 4x y squared plus 3 equals 4 dy dx. Okay. All right, so to get the dy dx's on the same side, it's going to be easier if I just take this one and move it to the other side. So we'll leave that. All right, I'm going to go ahead and factor out the dy dx as I do that. So that 4 would be left, and then that term, when it moves across, is negative. So I'm going to get negative 4x squared y. And then I can divide both sides by that. And looking at that answer, I'm trying to decide, will it reduce? No, I don't see anything that goes into all 4 terms. So that is just my answer. So I hope the implicit differentiation makes sense to you. Okay, so let's do our related rate examples. So you have some notes on the related rates. And let's make sure we go through those. Okay, so related rates, remember those are problems where you have variables that are functions of time. And so we're going to have to follow, anytime we take a derivative of y, all right, we follow it with dy dt because we're using that dt now because we're functions of time. And anytime I take a derivative of x, I follow it with dx dt. So you're going to have a problem like this. Let x and y are differential functions of time, and let x squared plus y squared equal 25. When x equals 3, y equals 4, and dx dt equals 8, I want to find dy dt. I meant to say let x and y be differentiable functions of time. All right, so start with that equation that they gave us. And you're going to take the derivative implicitly. And so every time you take a derivative of x, you follow it with dx dt, and every time you take a derivative of y, you follow it with dy dt. And then we're going to plug in these quantities that we know over here. All right, so if I take the derivative of x squared, I get 2x dx dt, and the derivative of y squared would be 2y dy dt, and the derivative of 25 would be 0. So I'm trying to find dy dt. That's the one I want to solve for. So I'm going to replace all of my other ones and then solve that out. So I'm plugging in for x. X is 3. All right, dx dt is 8, and y is 4. So if I multiply that, 2 times 3 is 6 times 8 is 48, plus 8 dy dt. And then if I move that over and make it negative 48, then I can just divide by 8. And I get that dy dt equals negative 6. So these are pretty easy, nothing too bad with these. So let's do these last two. All right, x and y are differentiable functions of time, and let xy be 4. Okay, and then I've got everything I plug in and I solve. Now remember, x and y are together in the same term, so I'm doing that product rule. So 1 would be x and 2 would be y. So d1 is just 1 dx dt. Sorry, my pen has decided to quit working. Let me try it again. So d1, derivative of x, would be 1, follow it with dx dt. There it goes. And then d2 would be derivative of y would be 1, follow it with dy dt. And you can write those ones if you want to. All right, so 1 d2 plus 2 d1, and it equals the derivative of 4, which is 0. Okay, so let's plug in what we know. It says x is 8. All right, dy dt is what I'm solving for. All right, y is 5, and dx dt is 10. So I can solve this out. That's a plus, sorry, 50 equals 0. Take that to the other side. And then divide by that 8. And I'm just going to reduce that fraction. It'll reduce by 2. I get negative 25 over 4. All right, so you will have a couple of related rate word problems. I kind of gave you some guidelines about reading, labeling everything that you know, and solving it out. But I did put a note on there that if it says the word rate by it, it's a dx dt, and I'll show you what I mean. So let's look at this last one really quick. Company that manufactures sports supplements calculates that its cost and revenue can be modeled by the equations C equals 125,000 plus 0.75x and R equals 250x minus 1/10 x squared, where x is the number of units of sports supplements produced in 1 week. If production in one particular week is 1,000 units and is increasing at a rate of 150 units, find the rate at which the profit is changing. So what I'm trying to do is find the rate of change of profit. So it's asking me to find dp dt. Okay, it gives me 2 numbers in here. I get 1,000 and I get 150. One of them is x and one of them is dx dt, and the one that has the word rate in front of it is the one that's dx dt, and so that makes the x the 1,000. So before I can find dp dt, I have to actually find profit. Well, profit is revenue minus cost, and remember we want to bracket off that cost, so we distribute the negative. So revenue would be 250x minus 1/10 x squared minus the cost, which is 125,000 plus 0.75x. So if we distribute the negative, and if I clean it up, I get that I can put like terms together. So this 250x minus the 0.75x, I get 249.25x minus 1/10 x squared minus 125,000. I'm going to run out of room. So when I take the derivative now, derivative of profit would be 1, follow it with dp dt. All right, if I take the derivative here, I get just 249.25. Follow it with dx dt minus, all right, 2 times a 10th is 1/5 x, follow it with dx dt. All right, and then I can plug in those quantities that I know. I'm going to plug in for dx dt 150, and I'm going to plug in 1,000 for x and 150 here. And I'm running out of room to do that math, but when you do that math, you should get 7,387.50 as your answer. So to go try that, my math lab.